Okay, everybody. We don't have anybody here for the SI session, and so I don't really know about that. I really thought tonight would be big, but I guess what I'm going to do, since we don't have anyone here, is I've been doing algebra a really long time, guys, so I kind of know the problems that tend to throw people for loops on the exam. So for those of you that might be out working or something tonight and maybe you can't make this time and you're planning on watching the recording later, I was kind of hoping to do questions that people had, but what I'm going to do is pick 3 or 4. We'll see how many problems. I just opened a book here. I'm going to pick some problems that are topics that tend to get people on the exam. So the first thing that we're going to do is we're going to go back to section 4.6. So I'll just put this right here. And if you are just, wanting to know what section I'm talking about, what we're going to do is find the inverse of, and we'll just make one up here. So let's see, or actually, maybe we'll get one out of a book. Let's go ahead and do one that's got a weird little root. So we'll do the inverse of the 7th root of 3x plus 4, okay? So if you all will remember, you've got some steps that we need to use when we're doing the inverse. And so the first step that we did is we kind of replaced this f of x with y. And so I'm going to call that y equals the 7th root of 3x plus 4. And then the second step that we do on these is we take your x and y and we switch them. And that's really crucial because an inverse function, that's what it really does, is it kind of switches your x and y. So basically that means everywhere that we see a y, we're going to put an x. Everywhere we see an x, we're going to put a y. And then what you have to do is solve this. And so those first 2 things are kind of the easy steps. This part's kind of the part that gets a little difficult. So remember, you're trying to get y by itself. So right now, y is underneath that 7th root. So I'm going to change colors here for just a second. And I'm going to remind you, the only thing that will cancel out a 7th root is raising it to the 7th power. But whatever you do to one side in algebra, you must also do to the other. So over here, we've got this x to the 7th power. And so what we know is that that doesn't have anything to cancel. So that just leaves us with x to the 7th. But this 7th root right here cancels out with that 7th power right here. So this just leaves me with 3y plus 4. Now, so we're on our way now, but we're not done yet. What I need to do now is get rid of this 4. And since it's a positive 4, the only way that we can do that is subtract it. And that's going to leave me with x to the 7th minus 4 equals 3y. And now we're really almost done. The catch is now that we don't want 3y, we want 1y. And so we're going to divide by 3 on both sides. And over here, those 3's are going to cancel, and that leaves me with x to the 7th minus 4, all of that divided by 3. And so my inverse function, if you would like to write it like an inverse function, remember f with the little -1 means an inverse. And that is going to be x to the 7th minus 4, all divided by 3. So when you're studying for your midterm exam, once again, this is section 4.6, okay? I'll go ahead and tell you, for those of you that are going to take the time to watch this, there are a couple of questions off of section 4.6, so you want to make sure that you've gone back over how to find an inverse function. Remember, you take your x and y and you switch them, and then you do whatever you have to do algebraically wise to come back in there and solve that for y. All right, so if y'all will give me just a second, we're going to erase this. And I think I'm going to go back one more section. So the inverse function was section 4.6. So I think now we're going to go back and we're going to do something out of section 4.5. Now 4.5 had a couple of topics, and we probably won't do all of them. But the first thing that we're going to do is do something called the composition, and that's because composition tends to be a little bit newer in there. So let me give you two functions. So for right now, we're going to let f of x be, how about 3x plus 8? And we are going to let g of x be x squared. Okay, so we're going to do a couple of things with this, and but we're going to use the same f and the same g throughout the entire part of here. So the first thing we're going to do, I'm just going to call this part A, is we're going to come in here and we're going to find f with this open circle g of x. And so what you need to remember is that little open circle means composition. And so the way that I usually do composition is I try to remind you that means f, but what you do is you plug in g of x. Okay, so having it on this whiteboard is kind of nice. So what you want to do is you want to look at this g of x. Well, g of x was given to you. I had to give that to you in the problem. G of x is x squared. So what I want to do is I'm going to come in here and I'm going to say, hey, I don't really want g of x in there. I want what g of x is equal to, which in this case is x squared. And so now that you have taken out what g is and put in what it's equal to, then what you have to do now is you have to go over here to function f. And remember, function f is right here. I'm going to underline it. And everywhere you see an x, which is right here, you are going to put in exactly what we have. So if we go to function x, we have 3, but instead of putting in an x, we're going to put in this, x squared, and then we're going to finish function f plus 8. And then if you could do anything algebraically wise, you would want to. Unfortunately, in this problem, or maybe fortunately, I don't know how you feel about that, but we can't do anything with 3x squared plus 8. You can't combine any like terms. You can't do any multiplying. Don't try to make this hard and set it equal to 0 and solve from there or anything like that. You're just kind of simplifying it. But now if you will remember, not only could we do f composed with g like we did in part A, we could also do g composed with f. And remember here, the order makes a difference. So g composed with f means that we are going to take f of x and plug it into g. So it's the same kind of thing, but you'll notice that our order of our functions is a little bit different. So now I've got g, and I want to plug in f of x. Well, once again, f of x was given to you. It has to be. So that is 3x plus 8. So that first part is really just kind of a substitution part, if you will. And now what we're going to do is we're going to come over here to g, and g is just x squared. Well, what we're plugging in for x is 3x plus 8. And so what I have here is 3x plus 8, but I need to now square it. And you can do one of two things. I'll be real honest. If this was a problem on the test and you didn't actually FOIL that out, I would go ahead and give you credit for it. But if you did FOIL it out, then I would, of course, give you credit for that answer as well, because algebraically they're the same. I want you to notice, since they're sitting side by side in front of you, how close they are, but there really is a big difference between these two functions. And so if I give you, well, I shouldn't say if, when I give you a composition on the midterm exam, you need to pay really close attention to whether it's f composed with g or whether it's g composed with f, because that can make a huge difference in your answer. All right, so now let's do this. We're going to leave our f and g, okay? I'm not going to change them at all. And we're still going to be talking about section 4.5. Not going to change that at all either. What I am going to do is do something different. We're not going to do composition, and we're not going to do all of these, but I'll go ahead and call this part C. So let's try this. Let's do f of, oh, how do I want to do this? Let's do f plus, we'll just do plus g of 3. Okay, actually, you know what? Let's not do 3 because I have a 3 in that answer and I don't want that, or in that problem, I don't want that to confuse you. We'll do f plus g of 4. So remember what this really means is this. This means what you want to do is find f when you plug in 4 and add it to g when you plug in 4. Okay? The reason we know that this is addition right here is because over here in the problem it is addition. So f of 4 means come up here and in problem f you see 3, but instead of x you're going to plug in 4 plus 8. And if you want to, you can go ahead and think about that and go ahead and just get a number. You don't have to, but I'm going to go ahead and do that. So 3 times 4 is 12 plus 8, and so that simplifies to be 20. And then we're going to come over here and we see g of 4. Okay, well, g is over here. So g says take whatever you've got and square it. So that is 4 squared. 4 squared we know is 16. So now we have our two numbers. We have 20 over here. We have 16 over here. 20 plus 16 is 36. And there's our answer. Now, I want to remind you before we go on to another problem that nobody ever promised you it had to be plus. I just picked plus right there. So for just a second, I want you to think about this. If I were to not have picked plus, they're working on my building. I don't know if y'all can hear all that noise outside, but they are hauling carts in and out. They're fixing the floor in our office building. So I'm sorry about the noise if y'all can hear all the carts that are going on behind me. So let's pretend for just a minute that instead of a plus, I put a multiplication symbol right there. Now I'm trying to fill that in because I don't want you to think it's composition, because composition is a big open circle. This is a closed circle, so that means multiplication. The only thing that changes here, guys, is you're still plugging in 4 because I still have a 4 right there. But instead of a plus right here, we would have a multiplication symbol right here. And so you would still figure out what f of 4 is. It would still be 20. You would still figure out what g of 4 is. It would still be 16. Oop, that doesn't look like a closed circle to me. There we go. Let's close that in. But then when you get to this final answer, well, 20 times 16 is not even close to 36. In fact, it's late and I'm old and I'm tired, so I'm going to double check it on my calculator. So here we go. So 20 times 16 would be 320 for my answer. So if you'll remember, when you do these problems, or when you did these problems in section 4.5, you had all 4 operations that were there in these problems. So you had f plus g, you had f minus g, f times g, and f divided by g. And they're all the same principle. It just depends what they give you in the problem as to what you're doing with those two numbers at the end when you simplify and give me that final answer. Okay, let's see. I'm looking over your review here. Let's go all the way back to domain and range, because sometimes domain and range gives people just a bit of a problem. So let's do a couple of problems on domain and range. So the first thing I'm going to tell you is this, in case you're wanting section numbers so that you can go back and look at your homework or something specifically. This is section 4.1. It's right where we started with the credit level portion of this course. And what I'm going to do for this first one is I'm going to draw you a picture. Now I'm going to tell you, and I've probably mentioned it before, y'all, I am an awful drawer, like bad. It's really bad, really bad. Can't even draw a stick figure. So I'm going to do my best. I'm going to tell you that what I'm intending to draw you is going to be a square. So it's not going to be perfect, but just trust me, I'm trying to draw a square here. So I'm going to start here at -1 right here. On the y-axis, I'm going to go up to +1, okay? And then I'm going to go all the way over here to 2 on the x-axis. We're going to go over here and then go straight up. So since I'm not on graph paper and since I'm kind of a lousy artist to begin with, I'm going to go ahead and tell you what the coordinates of these points are just to be clear. So this is x is 2, y is 1. This is x is 2, y is -1. This is x is 0, y is -1, and this is x is 0, y is +1. Okay, so we've got this box. So I can ask you lots of questions about this box. So let's go ahead and just start investigating. The most common one that you probably remember, because we did quite a few of these in this section, was we would ask you for the domain and range. So if you'll remember, domain is your x's. And so if I was in a classroom where you could actually see all of me rather than just this little bitty blurb over here on my screen, I would tell you to remember that domain is left and right. It is your x-axis. So if you want to, you can just kind of draw yourself something like this. Left to right for domain, and then range is up and down. Okay, so our domain, left and right, so that's this portion of the box. Now you should probably agree with me that this portion of the box covers the same part of the x-axis as that portion of the box does. So remember, we're going side to side, left to right here. So you always want to go from the left to the right. The reason is it has to be small, comma, big. So you can never go right to left. Think the way you read across a page. So left all the way over to right. So the smallest x value that we ever have is 0. And then we go all the way to the x-axis up until 2. So we've got 0 to 2, but now the other thing that really gets students a lot of times is your endpoints, because they can't remember, oh my goodness, am I supposed to put a parenthesis? Am I supposed to put a bracket? What's the difference? I've forgotten. So let me remind you, a bracket means that your graph that you're looking at actually touches it. And you can see my box touches 0, and my box also touches 2. So we're going to have brackets on both of those. Remember, one more time, just as a reminder, you can't say 2, 0, because it has to go small, comma, big. All right. Now for your range, it's the same kind of thing. It has to go small, comma, big, but your range isn't this way. Your range is this way. So what I tell people to think of on this one is you have to think of the bottom to the top. Or you can say floor to ceiling, however you kind of want to think about that, but you have to start small and then you get big. So I'm going to do a different color here so that it kind of stands out. So let's do, we'll do kind of a greenish here. So we're going this way this time. So the smallest thing that it hits on the y-axis is -1, and it does indeed touch that. So that's a bracket. Comma, and then the biggest thing that it hits is +1, and once again it touches that, so that's a bracket. One more time, you can't say 1, -1, has to be -1, 1. All right, give me 1 sec, guys. Okay, so now that's domain and range. The next thing that kind of followed with a lot of those was then they would say, is this a function? Well, you know, the good news about that is I guess it's a yes or no question. You got a 50-50 shot, but nobody ever really wants a 50-50 shot on a test. So you really have to think about this. So here's how you determine if it's a function. You use what we are going to call the vertical line test. Now remember, vertical means up and down, okay? Vertical, this way, up and down. So if you can come over here and you can draw me a line that hits that graph in 2 points, and I'm just going to draw this one right here, it hits that graph in 2 points right there, then it is not a function, okay? So anything like a box would automatically not be a function because you can hit it in 2 points. Anything like a circle, think about that, not a function because we can hit it in 2 points right here. So is this a function? The answer is no. But usually when we say no, they say, okay, you can't have just a 50-50 shot. You got to give me a reason. And the reason would be because it crossed in these 2 points right here. Now, there are lots of points that you could give me for an answer, but since I drew my points right there, I'm just going to use these. Well, the reason that it's not a function is because it goes through the point 1, -1, and it also goes through the point 1, +1. Now, I happened to give you 2 points that were kind of in the middle of that graph. You didn't have to. You could have used these 2 points over here on the end. And so you could have said, hey, it cuts it here and here, so it's not a function. And then your point would have been 2, -1 and 2, +1. Or you could have come over here and you could have said, oh, look, I used this point. And so my points that prove it's not a function are 0, -1 and 0, +1. So it's not going to be a function, but the points that you give me can vary from student to student, and they can still all be 100% correct. So if you happen to be working on your review with a buddy of yours, and you say it's not a function and they say it's not a function, and then y'all both get different answers for the points that prove it, that's really okay. Perfectly acceptable, not a problem at all. All right, so now let's look at something that's a little different. It's still going to be domain and range. But it's not going to be on a graph, or I shouldn't say domain and range. On a problem like this, we only asked you domain, so I won't ask you range on this one. But I'm not going to give you a graph. You're going to have to think of it algebraically. So for this one, I'm going to say, okay, f of x is going to be the square root of x plus 2 underneath the square root. And then I move that -5 kind of over this way because I don't want you to think it's underneath the square root. And so what I want you to do here is I want you to find the domain. So this is what you have to remember on a problem like this. There are really a couple of ways to do it. For those of you that are real familiar with your graphing calculators, you could graph this and probably read the graph well enough, just like we did that last problem, to get the domain off of that. I'm going to caution you, if you do that on the test for your work that you have to upload to me, please make sure that you graph it and say, you know, I read the domain off the graph. And that would be sufficient for me. Now, if you're not real familiar with your graphing calculator or anything like that, and you want to just do this algebraically, what you have to remember is that whatever's underneath the square root has to be positive. And so what we do is we say, okay, x plus 2 has to be greater than or equal to 0. The reason for that is you can't take the square root of a negative number. If you don't believe me, plug it in your calculator. Do something like square root of -2. It's going to spit an error message back at you. It doesn't like it. So x plus 2 has to be greater than or equal to 0. You notice in this problem right here, I could care less about what's over here. That's not underneath the square root. It does not affect my domain. This -5 could be negative an elephant for all we care. It doesn't make a bit of difference in the problem. The only thing that makes a difference in this problem is right there, what's underneath that square root. And we always set it greater than or equal to 0, always. And then what we do is solve it for x. Okay, so we have x plus 2. Well, the way to get rid of a plus 2 is to subtract it. And so that says x has to be greater than or equal to -2. Well, now that's great, and you're almost done. But what Hawks always says is they write this thing that says this. You have to write the answer in something called interval notation. And that's exactly what we did on that last one. It's just that sometimes interval notation is a little easier to read off of a graph. So what I tell students is to think about it like this. Think about a number line. You've got your value -2 somewhere. What you know, according to this number sentence that we have here, is x has to be greater than or equal to it. So it can equal -2, or it can be bigger than -2, but it can't be on the other side. So think about your domain, again, that we talked about last time. -2 is the smallest thing it can equal, and then it gets bigger, and it keeps getting bigger. So we're going to say -2, comma. The way to say that it keeps getting bigger is to write infinity. Now we have to think about our endpoints. Since it can equal -2, it actually touches it. That's a bracket. But infinity is an idea. Infinity is not a solid number like 100. Because if you said, well, it could go all the way to 100, I'd say, well, it could go to 101. Or if you said, nah, it can go to 1,000, it can go to 1,001. So it can keep getting bigger. So basically, it can always one-up us. No matter what number we say, it can go a little bigger. And since we can't actually touch infinity, there is always a parenthesis on infinity. You will never, ever find an instance in mathematics where there is a bracket on an infinity. So this would be our answer for our domain. All right, give me a second. I'm looking for another problem. Let's see. I want to do one more type of problem here, but I don't want to do them that has numbers that are just ridiculously big. So okay, I found one. Let's do this. Now this is going to be our last problem that we go ahead and do. And it's going to be the very last topic that we did. Okay, so section 5.3, very last thing. It'll help us review section 5.2 also, because 5.2 was, oh, I did not mean to do that. Hang on just one second. Now I can't make it bigger. Well, that's not very funny. We're just going to do this. We're going to maximize it. There we go. All right. Section 5.2 was synthetic division. We're going to need to use synthetic division in the middle of this, and it's going to help us review section 5.1 because we're going to need the quadratic formula in the middle of this as well. So this one problem that I'm fixing to do is going to review kind of all of chapter 5 at one time. So what we're going to do is we are going to solve the following. And these are long, guys, so I will do my best to get most of it on one screen, but I'm afraid that we are not going to be able to do that. So when we're doing this, if I have to erase some stuff, then y'all know that we can, you know, let me think about that for a second. I don't really think I like that problem. Let me think about that. This is what I get for pulling something out of a book. Okay, yeah, nix that one. Sorry, guys. That one's got a trick, and I don't want to give you, I want to give you one that's a straightforward something or another. I don't want to give you one that's a trick today. So no tricks. So let's do this one. X cubed minus 3x squared plus x minus 3. Okay, so let's do this one. It's still going to cover all the basics, but it doesn't have a trick in it, and I don't want to give you something that had a trick today. So this is a third degree equation. If you don't remember what a degree is, I'm going to put it right, a little star right there. That's the highest exponent. And the reason that that's important is that tells you that you are not done with this problem until you have 3 answers, all three. If I give you an x to the 4th, you got to have 4 answers before you're done. So we need 3 answers. Well, that's great. You know, since this is an x to the 3rd, you can't just plug it into the quadratic formula because the quadratic formula only works if something is the highest power of a 2. So this doesn't work in the quadratic formula. So what we're going to have to do is we're going to have to go back to that method that we learned in section 5.3. So what we're going to need to do is first, we are going to have to come up with, so I'm going to call this step 1. We're going to have to come up with our possible rational zeros. So we abbreviated that as possible rational zeros. So what that means is that you will need factors of 2 numbers in here, if you remember. You need factors of -3, this last number. Well, the only numbers that are factors of -3 are plus and minus 1 and plus and minus 3. And then you need factors of the first number in the problem. Now, the first number in the problem should be right here, and you'll notice there is no number, but remember that means a 1. So the only numbers that are factors of 1 are plus and minus 1. That's it. And so the way that you come up with your list of zeros is you put these numbers in the top, these numbers in the bottom. So my possible rational zeros, or my P's and Q's, sometimes they call them, are plus and minus 1 over 1 and 1 over 3. Now you can't quite input it into Hawks like this because we know that 1 over 1 can be simplified to just be the number 1. So when you're putting these into Hawks, if it asks you for your list of possible zeros, you'd have to make sure that you simplified that. So just plus or minus 1. Now, step 2, and I can't really show you this very well via Zoom, was to plug it into my calculator. So I'm just going to put calculator right here. If you'll give me just 1 second, I'm going to reach over here. I'm going to grab my calculator. I'm going to plug this equation in. So let's see, that's going to be x to the third minus 3x squared plus x minus 3. And then I'm going to hit graph here. Oh, and I've been doing something funky with my calculator, so I don't have a standard window. So give me 1 second. I got to get my standard window back. And I'm going to kind of draw what my calculator shows me just so that we can kind of talk about it here. So it looks like here. So it looks like it kind of goes curve up there. Okay. Kind of down this way over here, kind of curves up there. So remember, what you're looking for, a solution or an answer, is the same thing as an x-intercept. And so my calculator kind of gives me a hint. My calculator shows me that it crosses the x-axis right here, okay? Oh my goodness, y'all. You know what? I realized I just made a mistake. Let's back up. This is what I get for talking fast. Let's back up and let's look at that PRZ. This is a good teaching moment because, first of all, nobody is perfect. Second of all, I just realized by looking at the graph that I had made a mistake. And sometimes you can put things together and that shows you what you've done. My graph crosses the x-axis at 3. That means that that should be part of my possible zeros. But look up here what I did. I put 1 over 3 instead of putting the top number first, and that should be 3 over 1, and 3 over 1 simplifies to be 3. So that showed me that I made a mistake, and so if something like that happens to you on a test, of course you can go back and fix it. So that's kind of a good thing. Look, my graphing calculator said, hey, you made an error here. You better go back and look at it again. So I know that 3 is an answer. That's great. The problem is that I need 3 answers here, and my calculator doesn't give me any other help. So what we're going to have to do is now go to step 3. So if we go to step 3, I'm going to have to erase this. What we want you to do is prove it with synthetic division. And most of y'all really liked synthetic division. So hopefully that won't be too bad. So step 3, synthetic division. So I'm just going to put an SD right here. So what we're going to do is we're going to set up our synthetic division here. And what we're going to check is we're going to check 3. The reason we're going to check 3 is because 3 was what my calculator told me. So my numbers in my function are 1, -3, 1, -3. Now remember, you always start synthetic division by bringing down the 1. So 1 times 3 is 3. We add those up, we get 0. 0 times 3 is 0. We add those up and get 1. 1 times 3 is 3. We add them up and we get 0. And remember, this is what you're looking for. This is crucial. If you get 0 right there, that means 3 is an answer. Yay! What that also means is that you've just made this a smaller problem. You started out with a cubed. So now this is a 1x squared plus 0x plus 1. Now, y'all know almost no one is going to write a 1x squared plus 0x. What they are going to write is x squared plus 1. And we can set that equal to 0 now. Now what you have is you have a quadratic equation. Okay? So remember, you needed 3 answers. My synthetic division just gave you one of them. So I'm going to put it up here. My synthetic division told you that 3 was an answer. That's great. But now what I'm going to have to do is I'm going to have to use the quadratic formula to get my other 2 answers. So remember, the quadratic formula needs an A, it needs a B, and it needs a C. Well, A in this case is 1x squared. B is 0 because there are 0 x's. C is also 1. I'm going to write the quadratic formula right here for you, and I'm going to promise you now, because I wrote the test, you have to know it more than once, actually. So you will have more than one problem that you're going to need the quadratic formula on to solve. So please make sure that you remember that. So now let's plug in. So we have negative b, well that's 0, plus or minus big square root sign, b, 0 squared, minus 4 times a, which is 1, times c, which is 1, over 2 times a. Well, now what we're going to do is clean that up. And so probably the easiest thing to do would be this. I don't need all those zeros. 0 is 0. So I don't need this negative 0. So just kind of forget him. So we just start plus or minus. I don't need 0 squared either. Negative 4 times 1 is just 4. Over 2 times 1 is 2. Now this is a good one to remember as well. It's a good one to practice. If that just said the square root of 4, you would all tell me the square root of 4 is 2, but that says the square root of negative 4. So remember, when you have a negative number underneath there, that gives you an I. So this is 2I because of the fact that an imaginary number is required when you take the square root of a negative number over 2. And then these 2's can cancel out. And so your other choices are positive I or negative I. And remember, you were looking for 3 answers. You found one of them in the fact that 3 was an answer. We got that from my calculator. The other answers you got from the quadratic formula, positive I and negative I. All right, so as we wrap up, I'm going to remind you of a couple of things. Number 1, there is a review on WebTest. It's called midterm exam review. It is set up so you can do it an unlimited number of times. You can pause it, you can come back to it, you can do all of those kinds of things. You must do it at least once because it's a grade. Nobody wants a 0. You should do it more than once because what happens when you do it often is that it regenerates problems. And so not only is that going to help you practice because it's going to show you different kinds of problems, but it's also going to help you kind of hone in and see what types of problems are going to be on that exam. When you are doing that, make sure that you are not relying on your calculator. I'm going to promise you now, if you just plug something in and you show me what your calculator does and you don't do any work, I won't give you any credit. If you go back to the syllabus, it says work is hand graded. So just because your calculator gave you the answer does not mean you get credit for the problem. You have to know how to do it. Use your calculator as a checking tool. Make sure that when you're working on your review, obviously, if you have a question, ask somebody, ask me, ask Ms. Young, ask a tutor, whatever, but make sure that you work on it enough to where you can do it without assistance, because of course, those assistive devices are not going to be there when you take your exam. And so if you have to ask a tutor how to start a problem, that means you're really not ready for the problem should it appear on an exam. Remember that you only have until Friday of this week to take the exam, so make sure that you've done it by then. Also, remember that I really suggest that you not wait till the last minute because we won't open it back up. So if something happens and, all of a sudden, you've waited till Friday night at 10 o'clock to start the exam and then, you start feeling bad or something like that, we're not going to open that up. So I really suggest that you take it a little bit earlier, even if it's still Friday, earlier in the day. That way you're covered should anything go wrong with that. And of course, good luck on the test. Take your time. You've got 2 hours to take it. Time usually is not a factor for anybody, so don't let that bother you. But please make sure that you go through your review because it is a real test and your review will help you get ready for it. All right? Good luck, everybody.